I set a port, and then for each of these websites, I create one socket on which I begin a connection, and then I use this sleep just so that we can see the results one after the other, not interleaved, and make them readable. So for each website, I create a socket and I begin a connection. And when I got the connection, I have this callback on begin connect. And for all three cases, I have three different callbacks. What do I mean by three cases? The one with the callback, with using only callbacks, the one using tasks, and the one using tasks and await, the await mechanism. So this callback, once it just ends the connection on the socket, and I use these classes I just showed you to start the processing, to send the request to the server and receive the response and parse the header. So these methods are pretty much the same. I can open all of them, but the only difference is the class they use, the callback, processor task, or processor await. So then I will show you the first one. So processor callback, oops, this one, which is here. Now for the members, I store the socket connection, obviously, the website I'm trying to access. I keep a buffer variable and the size, where this is where I will be reading. So where the response will be, chunks of the response will be stored. Then those will be stored in a header. And these are variables are used for sending the request to that server for the header. So the constructor just sets some variables, and I think this is interesting, the most interesting part of this function, by setting this header, which will be used to access to make the request for the header. And I think I showed you. So after I create the class, I call this method called start processing, and in start processing, I just begin a connection. On the connection, I begin a send, and I use a callback, since this is a callback class called send callback. So when I receive the response, I end the send and I get how much was received. And based on this, I know what to do next. Should I make another send so that I send the whole request vector, or start receiving? And here I have just some logic that tells me, okay, how much do I need to send? The send size, actually no, the buffer size, or some custom size. So in case I have, like, the request has 42 bytes and I've already sent 40, I cannot send 10 more bytes because I don't have 10 bytes. I have to send the 2 bytes that are left. So that's the logic here. And once I sent everything, I start receiving, begin receive callback, pretty explicit. And here I again receive the size, and basically I just start adding to this header based on what I have in the buffer. And I'm looking for this, I'm not sure, combination of characters. So I know, okay, this is where the header ends when the body starts, so that I can just stop this cycle, because this is a cycle. At the end, I call another receive and another callback, and this repeats, and I can parse the header. And just to show you that it works, I have 3 websites, I think YouTube, LinkedIn, and eJobs. Yes. 1, 2, and 3. So if you want to see exactly, so this is the website title, the attribute we were looking for, content length, and the whole header is here. And so some websites have a content length of 0 because of these redirects, I guess, or move permanently. And then there is one. Yeah. There is one without the content length attribute. I think Google has content length. If I can add that, I think I'll get like a number here, not 0. So that would be the callback version. Then we can improve this by using tasks. The members, the variables are the same, the constructor the same. The only difference is when you start processing, you have this pipeline, I call it, where you initialize the sending, and when that's done, this will return a task. When that's done, you continue it with the receiving part. So I'll show you the send initializer first. Here, send initializer kind of creates a promise, actually a completion source. That's how it's called, a task completion source. And when this is done, it's returned, and we know, okay, we can go to the receive part. And for this to be done, I have to send. And when I send something, this also returns a task. I continue with this kind of a callback on send bytes. So this is what follows after you send. The send method is very similar to what actually, no, not a send method. So sending is very similar. It just applies begin send and end send, and it creates this local task completion source where I will set the result of the end send. So basically how much I sent. This one is returned. It goes here. It's continue with, and then the callback is called using this task. So I know how much I sent, and the logic on the callback is very similar to what I've showed you previously. And I just repeat the process until I'm done. And when I'm done, I can take the promise, which was created in the send initializer, and set its result to, well, whatever. We're not interested in it. We just want to tell it, okay, we're done sending. So then when this promise this method returns, it returns this task, which is done. Now, actually, when this task is done, then it will be continued with the receive initializer. Receive initializer doesn't have to return anything. I just call again the same kind of idea. You receive, and then once you have the data for that, you call the onReceive bytes. Receive, begin receive, and end receive. Same thing. Creates a local task completion source, which I set the value to how much I've received, and like onReceive bytes would be the callback. We could call it that, and here it is the same logic as previously. I think there is nothing changed here, really. Okay, unless besides this call for the recursion part. Again, you receive, and then when you continue with this callback.
Yes.
So then I can run it as well. It works very similarly. I mean, very similarly. It's identical. I mean, the output is identical. Okay. And then the last part is a better version. I would say better version because it's shorter in that terms. So it's this class with using tasks and await. So the constructor, I think it's similar. Yes. Start processing. Now, instead of having that ugly pipeline with continue it and all that, I can just await the send initializer. And when this is done, which is an async method, I can start receiving. Send initializer, well, it's maybe shouldn't have called it send. Oh, no, it's fine. So send initializer kind of initializes the send and has this logic of, okay, well, you haven't sent everything, await a send, and the send method is the one that does the begin send and end send thingy. So it still uses the task completion source. That's why I said it's a mix between tasks and the await mechanism. But I await everything here. And when this is done, then this is done. Receive initializer is called. And this one, what it does is it has the same logic as before, but everything is contained in an outer while loop, which is set to infinite, so true. And you kind of return when you have found the end of the header. And for this one, the size, basically how much I've sent, and also the buffer is populated by using this await method, receive method with await. And this one does the begin receive and end receive part, the ugly part, using these task completion sources. So that would be it. And let me just run it. It's similar. 1, 2, and 3. Just to check something, I think if I use Google, I get. Yes, no, I don't. Okay, I need a website with some content linked, I guess. I don't know. Okay, I won't search for one, but I think that's not the point of the lab anyway, that it should be working with these mechanisms. Yes, so if you have any questions, I'm here. If not, thank you for your time.
No questions. Well, it would have been nice maybe to have separate programs so that the async variant is with async from start to end, but it's excellent work anyway. So thanks a lot.
Thank you as well.
By the way, the colleagues can also ask questions if they want. Meanwhile, I see some people who came a bit late. So Avram George.
Yes, here.
Here, thank you. Bolos Hazi Alex. Still missing. Balin Flavio.
I'm here.
Thank you. And Burzo Andrei.
I'm here.
Thank you. Okay, good. Now, who was next? Bodica Septimiu.
I can start sharing now. This is lab 3. I have some matrices that I want to multiply. So the helper, I use static methods everywhere and I hard-coded these dimensions.
That's not very nice because it also means you cannot compute large tests. And 50 by 50 matrix is quite small.
I see. Then can I do it for next time?
Let's see what you have by now and then increase by hand there. And we will see the performance.
Okay, the first version is where I want.
By the way, is it possible to close the right-hand side of the Solution Explorer? Yes, that's better.
Yes. I want the matrix to be split independent of rows and columns, so to just squash it into a single row and to take the intervals. I call this split iterative. I have an increment and this is the logic that you can see. Have a map of pairs of each pair is an interval. I generate them like this. Keep the previous one and multiply I by the increment and have a single for loop for the whole matrix so that it's squashed. This means that I can then start threads with this callback vector prod1. I pass it the pair describing the start and begin of the squashed matrix, and I calculate x and y like this. If I run it on the first version, I get this time. I left everything 0 because I thought it doesn't affect the time. But I can change the init matrix to put random values.
No problem with that. I'd be happy to see a larger test, but until now, let's see a little bit the source code. So where could you show quickly, starting from main, how it works?
Sure. I need to show you the header of the no properties.
Okay, so main calls solver v1. Now let's see solver v1. We have it there. It does the split and it prints the matrix. So I assume the split also does the computation. So let's go deeper into split iterative.